Friends, welcome to the 24th lecture on module 1. We will take up couple of examples of 3-dimensional analysis and try to understand them using simple transformation in step by step procedure. Let us rewind back slightly and understand what we did in the last couple of lectures in 3-dimensional analysis. We said that for any member which is arbitrarily oriented in space with respect to the reference axis system, one need to estimate two parameters, namely the direction cosines and the psi angle. Three direction cosines, namely Cx, Cy, Cz, actually define the location of longitudinal axis of the member, that is xm axis with reference to the reference axis system. Please understand, Cx deals with cos gamma ij, Cy deals also with cos gamma ij, Cz deals with cos gamma ij, whereas in this case I will be related to xm and x, in this case ym and y, in this case zm and z respectively. In addition, the psi angle defines the location of minor principal axis. We should also agree that all parameters of direction cosines and psi angle are geometric dependent, that is, it actually depends on position or orientation of the member with reference to the reference axis system. Further, to make a very interesting statement, direction cosines of each member can be readily computed, but psi angle need to be carefully estimated. One can do two types of transformations. In fact, to be very specific, we should say types of rotations. One is y zx transformation, which will give you ultimately psi y. Another is z yx transformation, which will give you psi z. Please understand, the computation of angle psi computed from both the transformations are different. Okay. So, obviously, the rotation process enables aligning or alignment of x y z axis to x y z axis of the member. That is what we are trying to do. Okay. Let us take an example and try to understand how to compute this psi angle. So, we will do one example as shown in the figure now. So, let us try to So, let us mark the global axis like this. This is my x axis, this is going to be my y axis, and this is going to be my z axis, and this becomes my origin for the reference axis system, and I have 3 members. The third member actually is connecting this point to this point. So, now there are 3 members fixed at both the ends here. Okay. You are able to visualize this in a 3 dimensional space. Let us now mark the dimensions. Okay. Let us say this dimension is 4 meters, this dimension is also 4 meters, and the height is 3 meters. Okay. Let us name the members. This member is member 1, this member is member 2, this inclined member is member 3. Let us name the joints. Let us say this is joint 1, joint 2 and joint 3, and this is just resting at this point, let us say 4. Now, the question asked is determine the psi angle for all the 3 members of the space frame shown in the figure. Okay. Let us talk about member 1. you know the length of the member L1 is 4 meters, okay, length of the member is 4 meters. Let us choose the local axis of this member like this. So, this is my xm, ym and zm. For the second member, let us say this is my xm, ym and zm. For the third member, along the length is xm, ym and zm. Okay. So, let us say the member j and k and length of the member. Let us say the member 1, member 2 and member 3. For the member 1, j end is at 1 and k end is at 2, length of the member is 4 meters. For the member 2, j end is at 3, k end is at 2, length of the member is again 4, 4. So, if we calculate this, okay, you know this value is going to be, this dimension is going to be 5.656, that is root 2 of 4 meters, but I want to know this length. So, this length of the member will be, it originates at 2, j and k end is at 4, the length is going to be square root of 5.656 square plus 3 square, okay, which is 6.402, that is the length of the member 3. Okay. So, let us go to member 1. This is member 1 whose length is 4 meters. Now, xm of member 1 is oriented towards y axis, is it not? See here, xm is oriented towards y axis, therefore, we should use z y x transformation. Now, interestingly, the psi angle will be psi z, it depends upon what is the first transformation we do, okay, which is actually the angle between ym and y axis, is it not? Now, you can see here ym and the y axis is 90 degrees. So, now I can say this is 90 degrees. Okay. Similarly, let us do this for member 2. Length of the member L2 is again 4 meters. Now, you see the longitudinal axis of the member, that is xm axis of the member, xm axis of the member is oriented along x, is it not? Is oriented along x axis. So, one can do either y z x or z y x transformation. Let us consider y z x transformation. So, I will now compute psi y which will be the angle between ym and y axis. Let us see that ym is vertical, y axis horizontal. So, the angle is going to be 90 degrees. Let us go to member 3. Member 3, xm axis is neither aligned towards x, y or z, but inclined, is it not? You can see here it is inclined. In such situation, you can do both the transformation. Let us try y zx transformation. That is complicated. To understand this, let us do some more explanation. To understand this transformation, let us take a simple example to explain. Okay? Let us do that. Let us say I have a 3 axis system. Which is x, y, z. Okay. I do y, z, x transformation. Okay. I want to do y, z, x transformation. I have a vector which is placed arbitrarily, okay, and this is my xm axis. Okay. It will also be x beta axis. So, let us say this is my ym axis, and zm axis. Let us say if this is my x beta, which I am marking in red color, this is my x beta, this becomes my y beta, and this becomes my z beta. So, the psi y angle will be the angle between y and ym or z and zm, correct? Angle between y and ym, this is my psi y or this is my psi y. To understand this, what we should do, let us consider a point P in xm ym plane, that is this plane xm ym plane, okay, in the frame of x y z, but the point should be located, or let us say the point should not be located along the xm axis. Select any point, let us take this point, let us take this point, this is my point P. It is located in xy plane, okay, this is the plane, you can see here, this is the plane, but not along xm line. Okay. Now, I project this on the xm and ym planes, and then project it to z and x plane. Obviously, this will be z power p and this will be x bar p, because this is x axis, this is y axis. Okay. This is my jth end of the member and kth end of the member. So, P is the point located in xm ym plane, but not along xm axis. Okay. Having said this, we need to find out the coordinates of these points. Coordinates of this point will actually describe position of xp, yp and zp with respect to the reference axis system. Let us do this.